Hello and welcome back to Engineering Physics, and for today's video we would now be having an example of a projectile motion with an initial velocity at an angle below the horizontal. Okay, so in this example, a stone was thrown at an angle of 25 degrees below the horizontal at an initial velocity of 6 meters per second, and if the stone hits the ground measured 80 meters horizontally from where the stone was thrown, we would be calculating the following. So before anything else, let us just draw the figures for us to better visualize the problem. So suppose that this is now to be the initial position of the stone. And let's say that it was thrown, as said here in the problem, it was thrown 25 degrees below the horizontal. So if this is now to be your horizontal, so let's say that this is now to be your horizontal plane. This is now to be, let's say, 25 degrees. So with that, this is now to be our initial velocity. So let's say that this is now to be the value for our VI. Suppose that this is now to be equal to 25 degrees. So as you can see, below the horizontal. So its VI, or the initial velocity, is now to be equal to 6 meters per second. Okay, so once again, I will just be writing it here. So our VI is to be equal to 6 meters per second. Okay, so if this is now to be the initial velocity, approximately this is now to be the trajectory. So suppose that that is now to be the trajectory. So it is said in the problem that this was measured 80 meters. So this is now to be measured 80 meters from this particular point. Okay, so according to this problem, so for problem letter A, we would now be solving for the difference in elevation between the ground and the height where the object was thrown. So with that, guys, so this is now to be for our value that we will be solving for. So from this value, from this point up until the ground. So with that, this is now to be equal to y. So that is now to be our vertical displacement y. Okay, so for your vertical displacement y, that is basically, so y is equal to vi times t plus gt squared divided by 2. So we can easily solve VI. So take note that this should be VIY. So do not forget this. So this should be VIY. Though we still do not know the value for VIY, it can easily be solved since that is just 6 meters per second sine 25 degrees. But for our value for time, so we still do not know this value yet. Okay. So how can we solve for the value for time? So as you can remember that your range R is basically equal to VIX times time. So VIX times time, so VIX is to be the x component of your initial velocity, and time is of course the time. And since R is already given here, so that is now to be equal to 80 meters. So this is now to be equal to VIX times time. So for VIX, so suppose that once again, this is now to be the initial velocity of our figure. So VI is to be equal to 6 meters per second. Of course, it must have its own x component and its y component. So if for VIX, so VIX is to be equal to, so suppose that this is now to be equal to 25 degrees as given in the problem. So VIX is basically equal to 6 cosine 25. So adjacent side. And for your VIY, this is basically 6 sine 25. So getting the answer here, so 6 cosine 25. So this is now to be 5.4378 meters per second. So I would just be storing this to my calculator as x. So shift store x. So as you can see for alpha x, that is now to be 5.4378. And as for our VIY, that is 6 sine 25. So with that, this is now to be equal to 2.5357 meters per second. So I would be storing this. So shift store y. So, okay. So if I would be pressing alpha y, so that is now to be stored in my calculator. And for me to confirm that that is to be correct, if I would be getting the resultant of this, so if I would be getting the Pythagorean value of this 2, we should arrive at this answer. So with that, square root of x squared plus y squared. So with that, 6 meters per second. Okay, so with that, so for our VIX, this is now to be stored. So VIX times t. And for our t, this is now to be equal to 80 meters divided by VIX. So this is just to be x. So stored in calcu. So stored in calcu. So with that, the time it took for it to reach 80 meters horizontally is to be equal to, so 80 meters divided by alpha x. So 14.7117. So 14.7117 seconds. So I would just be writing it at the top here. So time is equal to 14.7117 seconds. And voila. So there. So we already know the time. So with that, we can now solve for our value for y. So for the difference in elevation here, so the value for Ry is now to be equal to, so VIY. So I have already stored it in my calculator, which is to be y. However, take note guys that this should be a negative value because it is to be going down. So as you can see, this is to be going down. So with such, I would just be modifying my VIY here. So with that, so negative y. So I would just be storing the new value for y, which is to be negative 2.5357095. So going back here, so y is equal to VIY, which is to be stored in my calculator, times t, which is to be 14.7117 seconds. So plus negative 9.81 meters per second squared times 14.7117 squared divided by 2. So with such, calculating this equation, so this now to be alpha y. So confirming, so alpha y times 14.7117 minus 9.81 divided by 2 times 14, sorry, so times 14.7117 squared. Okay, so y times 14.7117 minus 9.81 divided by 2 times 14.7117 squared. And our answer here is to be negative 1098.9139 meters. So with such, it is to be located 1 kilometer below. So from this point up until this point, this is now to be equal to negative 1098.9139 meters. Okay, so with that, once again, the value here, so y is now to be equal to negative 1098.9139 meters. Okay, so proceeding, so what is now to be the time it took the stone to land to the ground? So actually, we have already solved for that earlier. So time is now to be equal to 14.7117 seconds. So this one. So what is now to be the final velocity of the ball right before or as it hits the ground? So what that means is that we would now be solving for this particular velocity, which is to be the final one. So with that, we will now once again segregate our solution into two components. So that is to be for the x component and for the y component. So for the x component, so for our Vx, that is basically your Vix. Since whatever is to be your horizontal component for the velocity at one point remains constant throughout. So with that, so for our Vx, that is basically my alpha x in my calculator. So that is now to be 5.4378. 5.4378 meters per second. How about for y? So for y, so for your vyf, or let's say vfy, this is now to be equal to your viy, or the initial velocity, plus gravity times time. So basic. So with that, for our VIY, that is basically my alpha y in my calculator. So that is to be negative 2.5357 plus GT. So plus negative 9.81 times, of course, the time. So what is to be the time? So as indicated here, we are to get the final velocity. So it means that it would be at this point. So for the projectile to reach this point, it will take 14.7117 seconds. So with that, 14.7117. So I'm sorry if you cannot see. So I've just moved my figure. So there. And with that, so for our VFY, so that is now, oops, sorry. So this is now to be equal to, so alpha y. So alpha y minus 9.81 times 14.7117. So its final velocity is to be negative 146.857 meters per second. But take note that this is just to be the x component and this is just the y component. So for the resultant, so of course you would now be getting the resultant because once again, if this is now to be your vertical component, so let's say that this is now to be your vertical component, which is to be negative 146. So sorry. So negative 146.857, and for your horizontal component, that is to be 5.4378 5.4378 meters per second. So the resultant is now to be this. So this is now to be the resultant. And if we are now to get its angle from, of course, the horizontal, so if this is now to be your horizontal line, we would now be getting this particular angle. So this is now to be your angle theta. So with that, it is better if I would just be moving this to the other side since it would just be the same. And for your x component, so for our x component, I would just be moving it at this particular part. Okay, then solving for the resultant. So for the resultant R, or let's say that that is now to be your resultant VF. So VF is just the hypotenuse of this triangle, and that is to be 5.4378 squared plus 146.8575 squared. Take note, guys, that this is to be negative, but since it is to be squared, so it doesn't matter if you would still be including the negative symbol here or not. So with that, so our VF is now to be equal to, looking at the calculator to our left, square root of 5.4378 squared plus 146.8575 squared. So the final velocity is to be 146.958 meters per second. And as for its direction, below horizontal, so that is basically the arctangent of, if this is now to be your angle, the opposite is to be this. So opposite is 146.8575 divided by the adjacent, which is 5.4378. So with that, our angle is now to be equal to, so the arctangent of 146.8575 divided by 5.4378. So located 87.879 degrees below the horizontal. So with that, our answer here is now to be, so VF is to be equal to, so I forgot, 146.958. So 146.958 meters per second with a direction of 87.879 degrees below the horizontal. So there.